Today we're going to talk about the Pythagorean Theorem, and that's notes 7.2. So, let's get started. The Pythagorean Theorem, which most of you are already familiar with, is a squared plus b squared equals c squared. Okay, c represents the hypotenuse, which is always opposite the right angle, and a and b always represent your legs. Okay, A and B can be interchanged, but C always has to be the hypotenuse. So, a Pythagorean triple are three numbers that satisfy the Pythagorean theorem. So if I plugged in, for instance, 3, 4, and 5 into the Pythagorean theorem, it should work out. So I'm going to do that. I know that A and B should be 3 and 4 because 5 is obviously bigger, and that has to be the C. So if I work this out as 3 squared plus 4 squared, that should equal 5 squared. Let's see if it works. 3 squared is 9, 4 squared is 16, and 5 squared is 25. If you notice, 9 plus 16 is 25. 25 equals 25, so that checks, making those three numbers a Pythagorean triple. These are some other examples of numbers that satisfy the Pythagorean theorem, making them all Pythagorean triples. Okay, now we're going to use the Pythagorean theorem to find missing lengths in a right triangle. All right, so this one says find the length of the hypotenuse of this triangle, ABC. Okay, the first thing I'm going to do is I'm going to write out my Pythagorean theorem. And I'm going to come to my triangle here, and I'm going to label what sides of the triangle are A, B, and C. I know the hypotenuse is across from the right across from the right angle. That's C. And the two legs can be A and B. Doesn't matter which one's A or B. Now I'm going to plug them into my Pythagorean theorem. So that's going to look like this. 20 squared plus 21 squared equals C squared. That's my unknown. Now I'm going to go ahead and calculate this. 20 squared is 400. 21 squared is 441. And C squared, I can't do anything with that. Now I'm going to add these two together. That gives you 841 equals C squared. And now I have to undo this square. And to do that, you square root. That'll cancel that. So the length of the hypotenuse is the square root of 841, which calculates out as a perfect 29. Okay, we're going to do another example. This is example 2. Let's go ahead and write out our Pythagorean theorem. And label the sides. Okay, across from the right angle is my C. So I know 20 is C. And these are my legs, A and B respectively. Doesn't matter which one's A or B. So I'm going to plug them in. So that gives me x squared plus 8 squared equals 20 squared. Now I'm going to calculate my squareds. So it's x squared plus 64 equals 400. And I'm going to keep solving this using algebra. So I'm going to subtract 64 from both sides. X squared equals, that would be 336. Now to cancel the square root. Now if you notice, 336, that gives you approximately, well, that's going to be something pretty big. It's going to be a decimal. If that's the case, we have to split this, because it does say radical form. No decimals. So I'm going to write this as 2 square roots. And I got to figure out what perfect square goes into 336 evenly. 16 is my perfect square that divides into 336 evenly. And it goes into it 21 times. The square root of 16 is 4. And the square root of 21, well, that stays as the square root of 21. So that's the length of this leg. So a quick summary, I'm going to go back to example 1. When you're looking for the length of the hypotenuse, okay, you notice that we added during the work. If we go to the Second example, we were looking for the leg. Now, if that's the case, you can see we did subtraction during the work. So make sure you identify when it is you add and when it is you subtract. Okay, next example is kind of a real world situation. We have a baseball diamond. Okay, a baseball diamond is a square. Square has 90-degree angles. And it says each side is 90 feet. So that means between each base is 90 feet. Home plate and second base are at opposite vertices of the square. So here's home plate, and here's second base. About how far is it from home plate to second base? So I'm going to draw a line there. And notice I have two right triangles. This length is across from the right angle. So that means this is the hypotenuse, which is C. So a squared plus b squared equals c squared. A and b, I'm going to use the triangle on the right, would be 90 squared plus 90 squared equals c squared. That's my hypotenuse, which is that length between home and second. I'm going to go ahead and calculate this side here. That's going to be 8100 plus 8100 equals c squared. Now again, notice we're looking for the hypotenuse, so we will be adding. Put those two together, you get 16,200 equals c squared. Cancel out that squared by square rooting 16,200. And the approximate length is about 127.3 feet. Next we have the converse of the Pythagorean theorem. All the converse is writing the Pythagorean theorem backwards. So the converse is c squared equals a squared plus b squared. Now we use this to figure out if a triangle is a right triangle or if it's some other type of triangle. So in this diagram, I'm going to check to see if this is a right triangle or not. Now, this is potentially my right angle. 85 is bigger than the rest of the numbers, so this is my C. And the other two are going to be the A and the B. So I'm going to plug that into the calculation here. Let's see, that's 85 squared equals 84 squared plus 13 squared. Okay, if I calculate 85 squared, I get 7,225. If I calculate 84 squared, that's 7,056. Plus 13 squared is 169. So my question is, if I added these together, will it equal 7,225? And yes, it does. So those are equal. So this is yes. This makes a right triangle. Now if you have those numbers, if they do not equal out, okay? If c squared is greater than the other two squared added together, the triangle will be an obtuse triangle. If c squared is less than the other two squared added together, it's acute. So for an example, okay, if I had three lengths, if I had 3, 5, and 8, okay? 8 would have to be C, and these two can be my A and B. So if I plug those in, it's going to look like this. 8 squared. How is that compared to 3 squared plus 5 squared? Now I know 8 squared is 64. 3 squared is 9. 5 squared is 25. 9 plus 25 is 36. 64 is greater than 36, so that means this is an obtuse triangle, as it said up here. So to recap, if they're equal, it's right. If it's greater than, it's obtuse, and if it's less than, it's acute.